Hey everyone, today I'll be doing the Leetcode Biweekly contest. I just got back in time, and hopefully I'll do well this time, and hopefully Leetcode won't get rate limited. Wish me luck. I always go through the solutions after I finish solving all the problems. Oh no. Okay, please don't get up. Expected. Alright. We'll divide that by 3. Close. That's 523.10, 523.10. AC. Alright. Sure. Okay. Big. Void. Differences. Two full 0. Oh, that doesn't look good. Two full 0. Submit that. Alright, AC. Can pass through 1s, you can't pass through 0s. Okay, this seems like a BFS for distance. Wait. Okay, I probably have a BFS template for this. Oop, I didn't need that. What is that extra bracket doing there? So what do I want to say? Start. Okay. And grid yep. And this and it was in the is row in column 1 next or 0 next? Is 0 next? Pricing. Actually, it should be grid. So I want the distance price, then the row, then the column. Yeah. What do I want to output? Kth highest ranked. Return. Alright, we're gonna try that. Grid. Alright, we're gonna submit that. Please don't TLE. Please don't TLE. AC, thank you. I was very worried there. What does it want? 2 seats. Okay, this seems like just as a normal DP, but with a prefix sum as well. So seats. There's a number of ways. Okay. So I want to arrange backwards. If the current one is a seat, then I'm going to add it to the list of seats. If there's less than 2 seats, okay, so low equals to the seats, high equals to and then Okay, I don't think this is correct yet. It's 3, 1. Oh, why am I making this I? It should be S. Please. Should that be +1 or -1? -1 probably. Okay, let's try to debug this. 4, 6, 6. Oh. Should that be the other way around? Okay. So I need to get the elements in the range from low +1 to high. Okay, I'm not thinking properly. What am I doing? I should just. Okay, I'm going the other way. Okay, let me just try this brute force first, and let's just see if it works. Should be minus. That doesn't look correct to me. Is the answer here too? Okay, so the answer is 1 for the first one. Then 1, then 1. This one should be 0. Okay. This is not going well for me. When I'm in position 5. Four, 1, 0. It should be 3, 1, 0. So that's not correct. 3, 1, 0. Okay, that looks more correct to me. So I need to add sum of elements in from the range low -1 up to high -1. Low -2. Alright, we're going to try that. Instead of returning dp0, I'll just return dpn. 3, 1, 0. Okay, we're going to try that. Okay, that was so bad. I'm not expecting good rank at all. $18. Oh, actually, that's pretty good. I'm surprised. This person 17 minutes, so that person beat me, but this could still be alright. Anyway, I'm going to go through the solutions now. This problem, I believe, is on. I believe this problem's on binarysearch.com, so I recognized it instantly. The key idea is, well, obviously, let's say that there's n candies in total. We can get up to the floor of n divided by 3 candies for free. So all we're trying to do is we're trying to select floor n over 3 candies, and then we're going to subtract them from the total because so these are we're trying to maximize the total cost of all the candies that we can get for free. And basically this is a greedy problem. So if we sort one of the candies lists, for example 2, 2, 5, 6, 7, 9, this is this example but sorted. Basically the key idea is, like, obviously you can't take 9 for free and you can't get 7 for free, but you can get 6 for free if you take this block. And then basically you can do, this is a greedy approach. So the optimal approach is always to separate. We keep taking the 3 highest candies, the 3 most expensive candies, and then we'll get the cheapest one for free. And then we'll take the next block of 3 and we'll get the cheapest one for free. So that's essentially what my code is doing here. First, I'm sorting them in descending order. Then for each of the n/3 blocks, I'm going to add to my answer the sum of the 2 ones that we can't take. So this will be the sum of the 2 ones that we can't take. And then if, for example, n was not a multiple of 3, then whatever's left over, it can't form a block. So we still have to include that. And that's this part of the code. Anyway, that's the solution for part 1. Solution for part 2. Okay, so this is my favorite one of a data structure which I really like. It's called a difference array. And the key idea is if you take the prefix sum array of a difference array, you get back the original array. And you don't need to know that information to derive it. So for example, let's say our difference array is 2, 4, minus 1. And then I don't know what our starting element is, but I'm just going to say, like, assume the first element is 1, then we can reconstruct our array. So if we start with 1, then we know since the difference was 2, this must be 1 plus 2, which is 3. And we essentially keep adding on the elements to a running total, and then if we append that running total to a list, or taking the prefix sum of that list, we will get the desired array. So if I finish this example, the 1 went to 3, 3 went to 7, and so this is like the actual array. And that might be all well and good, but the main problem is we don't know what the first element is. But the key idea is, let's say instead of the first element being 1, let's say the first element was 2, then the resulting array would be the same as what we had before, but every element would be increased by 1. And if we change the first element by x, then every element in that array is going to be changed by x. So what I did was, let's just assume the first element is 0, and then so here I'm assuming the first element is 1. It doesn't make any difference to the code. Like, that could be 1 and that could be 1, and that's the same code. So let's assume that the first element is 1. Then here I know that the lowest here is 1 and the highest is 6. And even if I change the first element by 2, the lowest will be 3 and the highest will be 8. And the key idea is that the difference between the lowest and the highest elements, no matter what the first element is, it will be the same. In fact, it's just going to be the sum of the differences. So here, I'm assuming that the first element is 1, and I'm finding the biggest and the smallest number in this array, which is essentially what I'm doing here. And then what I'm going to try to do is I'm going to try to pick the first element, so to shift this range such that it lies between lower and upper. Now let's take a hypothetical example. Let's say of my array, big was like 6, and let's say big was 6 and small was 1. And let's say that the lower was 3 and the highest was 10, because why not? Basically, if the difference between small and big was to be greater than the difference between lowest and this should be lower and upper. So if this difference or the range of the array is greater than the range between upper and lower, then it's impossible, right? Because no matter how we shift it, we're not going to be able to fit it inside this range. However, if we can fit it, then we notice that here, like, the range is 6, kind of. Like, I mean, there's 6. Well, you can do it with 5 either. It doesn't really matter. I could do my code like this. That might be easier for explanation. Here the range is 5, and here we need to find how many ways can I take a range of 5 numbers inside a range of 7 numbers. So how many ways can I fit 5 consecutive numbers in a block of 7? And the answer is just 7 take 5 plus 1, because yeah, that's basically what I'm doing here. And then 0 if the range doesn't fit. So that's my explanation for P2. I hope that made sense. Okay, for K3, this is a very boring and standard problem. I'm glad I had my template code for BFS there. This is the first time I've actually used this template successfully in a contest. So I'm glad it didn't backfire, because often I get very scared when I'm using Python for these questions because I don't want to risk TLE. Basically, first, this is just a sorting question. We need to sort it based on these parameters. The price, the row, and the column number of a particular item we can get immediately from the grid. However, the only thing we don't know is distance. So we need distance as the shortest path from the start, and to find the shortest distance in a grid, or since the grid is unweighted, we can simply use a BFS. So this is the templated part. I just do a BFS of this grid to find the distances. So dist ij will represent the minimum distance from start to that cell, and if you can't get to that cell, I've represented it by -1. Now, for each element, if we are able to visit it, and it's within our pricing range, then I'm just going to append it to this list, and then I'm going to sort this list first by the distance, then the price, then the row, then the column number, as in the question. What I do is I sort this list, and I take the k greatest elements, and they ask me to return the cell. So I'm just returning the row and the column number. This was an extremely boring Q3. It's just kind of throw a bunch of things together, and then the BFS is pretty standard. So I didn't particularly like this question. Okay, here's the last code, which I had to change quite a bit in the middle of my contest because I wasn't thinking very properly. But here's the main idea. Let's say we define our DP. Actually, for ease, let's say it's one indexed. I don't think this one index part actually matters. So I'm going to one index this string, and I'm going to say that I'm going to let dpx be the be the number of ways for the first x characters of corridor. What I mean by this is, for example, if we're taking this string as corridor, and I pass in, and then dp4 is just the number of ways to divide the first. If we consider corridor to only be the first 4 characters, what would the answer be? That's basically what my dp state is. And in this question, it's actually a lot easier to do it bottom up. You can do it top down, but I imagine that you would need like an extra. It would be annoying. You'd have to either pass another pointer through your top down DP, or you would need to use a binary search, which introduces an extra log factor. So this is why I'm using the bottom up approach. Basically, my approach is let S be like the sorted list of positions of what is S? Seats. Then for each, and then I'm going to try to consider the current partition. So if we put in the dividers, we're going to break down our room into partitions, right? And then when I take a dpx, I know x must lie in some partition. So what I'm doing in my dp is I'm looping over this possible partition. So I could write it like dpx, and then for start of the partition in the range 1 up to x, if the corridor from start partition, if our current partition has 2 seats, then I'm going to increment my answer by the number of ways to divide the rest of the room, which would be dp start partition -1. So this is my basic idea of my dp. And right now this dp isn't very smart, because no matter how I do this, we have on states, and then the transition is either on, or it's on for the loop, and depending on if you check seats carefully, that potentially could introduce another O(n) factor. So that's O(n) squared or O(n) cubed algorithm, and that's pretty bad. Now the key idea is, let's say let's say corridor looks like SPP, 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 SP, and I'm trying to find the DP for this substring. And the key idea is that this current partition, the start of this partition, if you're considering this current string, the start of the partition must lie somewhere from this second S all the way, but not up to the third S away. A start partition can be anywhere in this range, and right now that doesn't help me very much. So this is my basic code. Let's ignore some stuff. Let's ignore this array for now. I'm just doing a bottom-up approach. First, as I iterate through the array, I'm going to generate the list of seats in increasing order. Then I know that the start partition, the highest possible value of the start partition is the second largest seat number, and the earliest and the lowest possible start of the partition is one more than the third. It's one more than the third largest seed, and if the third largest seed doesn't exist, it's just one. So what I'm trying to do is, for iron range low up to high, so for each start partition in this range, what I'm trying to do is I'm trying to increase dpi by dp start partition minus 1, because dp start partition minus 1 will be the number of ways to rearrange the rest of the room once I've decided the current divider. And the last thing to note is that since this is a range, basically as I do my DP, I'm calculating a prefix sum array at the same time. So PSA here stands for prefix sum array. And then when I want to find this range, so if I want to get rid of this minus 1, I can simply introduce it here. Remember here ranges are inclusive, so this is actually the range from low minus 1 up to high minus 1. And then, since this is a range of DP values which I'm trying to add, instead of doing this manual for loop, which takes O(n) time per transition, I can simply increase it by the difference of two elements in the prefix sum array. So you might notice that the sum of like dpx plus dp plus 1 plus dpy, that's just the prefix sum array of y minus the prefix sum array of x minus 1, right? So that's essentially what I'm doing here. It's the same thing. So I'm just doing prefix sum array of the upper one minus prefix sum array of the lower number minus 1, because that's how prefix sum arrays work. And yeah, and then once I've calculated this dp value, I just need to build our prefix sum array for the current position. So at any time, the invariant is after I is executed, dp and ps and the prefix sum arrays are correct for the first I positions, or I plus 1 if you count 0. And yeah, that's basically all of my code. The only thing I must be careful of is if low can be 1, and then 1 minus 2 can be negative. So negative indices aren't very nice, so you might have to handle that separately. I just made the prefix sum array and the dp array really big, such that if you take the prefix sum array of -1, you're still going to get 0, because it's going to wrap around to the other side, and that side's not going to be used. So that's why I made that n plus 5. And yeah, that's basically my solution for Q4. Now it's time to check how I did. And I somehow managed to get second place, so I'm pretty happy with that. A second place. I was not expecting second place because I was taking a stupid long time on this problem. Okay, I don't know how this guy took 10 minutes on question 3, but I'm glad he did, and thank you Yui for having a bug. My current rating is 3097, so that will definitely get me over 3100, and that's some substantial progress towards 3200. Anyway, thanks for watching this. Remember to subscribe if you haven't, and I'll see you guys next time.